Zix 427 couldn't understand what they were seeing. The alien mathematician had spent 3 cycles analyzing the combat data from the human ships, and nothing made sense. They kept making what seemed like mistakes, yet somehow these mistakes led to victories. The blue-skinned mathematician floated closer to the observation window of the Galactic Council's diplomatic vessel. Below them, the human warship TSS Endeavour moved through its training exercises. Its movements were both graceful and strange. Fascinating, isn't it? First observer Kralthun's deep voice rumbled from behind. The tall Maraxian's 4 eyes blinked in sequence as he studied the human ship's movements. They're breaking at least 6 fundamental rules of space combat mathematics. 7. Actually, Zix 427 corrected, their crystalline fingers tapping rapidly on the datapad. And yet their success rate is unprecedented. On the bridge of the TSS Endeavour, Commander Susan Miller watched the alien observers through the ship's cameras. She knew exactly what was confusing them. It was the same thing that confused every advanced species when they first encountered human battle tactics. Ready for the next demonstration? She asked her crew. The men and women at their stations nodded. They had practiced this sequence for weeks, knowing it would challenge everything the aliens believed about space warfare. Begin pattern Delta 7, Susan ordered. Her hands moved smoothly over the tactical controls. The Endeavour responded instantly, beginning a series of maneuvers that would look like pure chaos to their visitors. In the observation room, Zix 427's eyes widened as their instruments tracked the human ship's course. They're deliberately introducing random variables into their flight path. It's mathematical heresy. Dr. Peter Walsh, the human theoretical physicist assigned to explain their methods to the aliens, smiled slightly. He stood next to the observers, his gray hair neat despite the low gravity. What you call random, we call unpredictability. It's a core principle of human combat mathematics. The Endeavour spun in what appeared to be a wasteful spiral, burning more fuel than necessary for a simple direction change. But as the maneuver completed, the ship ended up in a perfect firing position, while maintaining maximum shield coverage. Impossible, Kralthun muttered. Their fuel efficiency is terrible. Their angle of approach leaves them vulnerable for 2.3 seconds. Their shield distribution is uneven. And yet, he trailed off, watching as the Endeavour's training drones failed to land a single hit on the ship. Dr. Walsh nodded. We found early in our space combat development that perfect mathematics made us predictable. Our enemies could calculate our exact moves, our precise responses. So we started adding what we call human factors into our equations. Zix 427 turned all 3 eye stalks toward the human scientist. Human factors. Fear. Susan's voice came through the observation room speakers. Surprise. Confusion. We don't just calculate vector angles and power distributions. We calculate psychological impact. The Endeavour suddenly cut its engines, letting momentum carry it while rotating on multiple axes. The move would give any targeting computer a nightmare trying to predict its course. The training drone shots went wide, their programming unable to handle the seemingly random movement patterns. Look at this pattern, Zix 427 said excitedly, pulling up a holographic display. They're introducing deliberate errors into their calculations, but the errors follow a pattern that only makes sense if you factor in. The mathematician paused, their color shifting to a deeper blue of revelation. If you factor in human intuition, Dr. Walsh finished. We've learned to mathematically quantify something that can't be mathematically quantified. It's a paradox, but it works. Susan's voice came through again, calm and professional. Beginning attack pattern Omega 3. The Endeavour's movement changed completely. Instead of the defensive spirals, it began a series of sharp, aggressive maneuvers. Each move seemed to waste energy and leave openings, but somehow these apparent weaknesses never aligned with the training drone's firing solutions. They're using probability manipulation, Kralthun realized, his military training helping him see the pattern. They're not trying to be in the perfect position. They're trying to be in the last position anyone would expect them to be in. Dr. Walsh walked closer to the window, watching his species ship dance through space. Humans learned long ago that in combat, the mathematically perfect move is often the worst move you can make. Your enemy expects it. They plan for it. They counter it. The demonstration continued for another hour. The aliens watched in growing amazement as the Endeavour performed maneuver after maneuver that defied traditional space combat mathematics. Each time they thought they'd spotted the pattern, the human ship would do something completely different. When the demonstration ended, Susan Miller joined them in the observation room. She was shorter than both aliens, but her confident stance showed she was completely comfortable in their presence. Commander Miller, Zix 427 greeted her, their color now a swirling mix of blue and green that indicated deep thought. Your ship's performance was educational. But I must ask, how do you plan such complex mathematical variations so quickly in actual combat? Susan smiled. We don't. We have basic patterns we train in. But in real combat, much of it comes down to instinct and experience. We use math to support our intuition, not to replace it. Instinct. Kralthun's 4 eyes blinked rapidly. You base combat decisions on feelings. Informed feelings, Dr. Walsh corrected. Feelings backed by thousands of hours of training, years of experience, and yes, mathematical principles. But principles we've adapted to work with human nature rather than against it. Later that night, after the aliens had retired to their quarters, Zix 427 sent a preliminary report to the Galactic Council. The message was short, but would send shockwaves through the mathematical community. Human combat mathematics cannot be fully understood through pure mathematical analysis. They have created a hybrid system that combines precise calculation with controlled chaos. Most disturbing of all, it works better than our methods. Recommend immediate deep study of human mathematical principles. They are not making mistakes. They are operating on a level we had not known existed. In her quarters, Susan Miller read the training reports from the day's demonstration. Everything had gone according to plan, which meant they had thoroughly confused their alien observers. She smiled, remembering something her old flight instructor had told her. The best math isn't always the cleanest math. Sometimes you have to mess up the equations to get the right answer. Tomorrow, they would show the aliens more, gradually helping them understand that human space combat mathematics wasn't primitive or flawed. It was just different, and in the vast darkness of space, different could mean the difference between victory and defeat. She looked out her window at the alien vessel, its perfect geometric shape reflecting the distant starlight. The aliens would learn, eventually. They would learn that sometimes the best calculations weren't calculations at all, but rather educated guesses backed by solid math and human intuition. That was the real secret of human space warfare, knowing when to trust the numbers and knowing when to trust your gut. It was a lesson that had taken humanity centuries to learn, and one they were now ready to teach to the galaxy. The Maraxian warship's command center was silent except for the soft hum of computers. Chief Mathematician X299 played the battle recording for the 20th time. On the large screen, Lieutenant John Carter's fighter squadron danced through space, breaking every rule of combat the Maraxians had developed over 1,000 years. Watch this moment, X299 said, freezing the image. The alien's 4-fingered hand pointed to where Carter's squadron split into 3 groups during the Proxima Centauri skirmish. By all mathematical laws, this should have been suicide. Second observer Vertel leaned forward, his green scales reflecting the screen's light. Yet they won. Not only won, but didn't lose a single ship. The recording continued. The human fighters seemed to move randomly, but there was something else there, something hidden in their chaos. The Maraxian pirates they had fought hadn't stood a chance, their mathematically perfect formations falling apart in the face of human unpredictability. I need to speak with their tactical expert, X299 decided. There's something we're missing. Hours later, Dr. Amy Rodriguez sat across from the alien mathematicians in the joint military facility near Proxima Centauri. She had brought data pads filled with human combat calculations, ready to explain what the aliens called their chaos factors. The key isn't in the math itself, Amy explained, pulling up a simulation. It's in how we use it. Lieutenant Carter's squadron doesn't just calculate where to be. They calculate where the enemy expects them to be, and then they're somewhere else. X-299's upper eyes blinked in confusion, while the lower ones studied the data. But their fuel consumption is inefficient. Their formation gaps leave openings. Their approach vectors ignore optimal angles. Amy smiled. Those aren't mistakes. Those are traps. She pressed a button, and a new simulation began. It showed a typical pirate response to standard military tactics, their ships moving in mathematically perfect patterns to counter the expected attack. Now watch what happens when we introduce controlled chaos, Amy said. The simulation changed. Now it showed Carter's actual battle movements. The pirates' perfect formations became a weakness. They couldn't adapt fast enough to movements that deliberately ignored mathematical efficiency. Your pirates calculated every possible optimal attack pattern, Amy explained, but they never calculated the suboptimal ones. Why would they? It doesn't make mathematical sense to choose a worse position. Except that's exactly what makes it work. Vertel finished, understanding beginning to dawn. The pirates' computers couldn't predict your movements because they were programmed to expect mathematical perfection. In his office at the fighter base, Lieutenant John Carter was reviewing combat footage with his squadron. He paused the recording at a crucial moment, where his fighters had scattered in seemingly random directions. Look at their response, he told his pilots, pointing to the pirate ships. Their targeting computers are trying to predict where we'll be based on standard attack patterns. But we're not using standard patterns. One of his pilots, Sarah West, nodded. We're using what my grandfather called the crazy like a fox approach. We look random, but there's method in our madness. Exactly, Carter agreed. Every mistake we make is carefully calculated. We know where they think we should be, so we make sure we're somewhere else. It's not about being unpredictable. It's about being predictably unpredictable. Back in the conference room, Amy was showing the aliens more battle footage. Watch how Carter's squadron breaks formation here, she said. To your eyes, it looks like they're creating vulnerable gaps in their defense. But the gaps are never where the enemy can actually exploit them. X-299 realized. They're drawing fire to areas where they appear weak, but are actually strong. It's like a game of chess, Amy explained, using a comparison she knew the aliens would understand. Sometimes you sacrifice mathematical efficiency to gain tactical advantage. You don't just calculate moves, you calculate psychology. Vertel's scales shifted color as he processed this. You're saying that the hidden variable in your combat mathematics is the enemy's own mathematical perfection. Their predictability becomes our weapon, Amy confirmed. The more perfectly they follow standard combat mathematics, the easier they are to defeat. Later that day, Carter's squadron ran a demonstration for the alien observers. They showed how their seemingly chaotic movements actually followed complex patterns designed to exploit enemy assumptions. Watch this maneuver, Carter said over the comm as his fighters performed a scattered retreat. Standard mathematics says we should stay together for mutual support. So the enemy assumes that's what we'll do, and they prepare to exploit the weaknesses in a standard retreat formation. His fighters suddenly split apart, each taking a different vector. The training drones, programmed with standard combat responses, couldn't adapt fast enough. They fired at where the fighters should have been, missing completely. But because we split up in a calculated way, Carter continued, we create confusion. The enemy has to choose multiple targets. Their formation breaks down as each ship tries to pursue a different fighter. And that's when we turn the tables. As if on cue, his squadron regrouped from completely unexpected angles, catching the drones in a crossfire they never saw coming. In a real battle, it would have been over in seconds. X-299 made careful notes as they watched. Your pilots must have exceptional mathematical skills to calculate these complex maneuvers in real time. Carter laughed over the comm. Actually, we don't calculate much of anything in the middle of a fight. We practice these patterns until they become instinct. The math supports our training. But in combat, we rely on experience and gut feeling. Gut feeling? Vertel asked, confused by the term. Human intuition, Amy explained. The ability to make split-second decisions based on experience rather than pure calculation. We've found ways to mathematically model it, but the real key is learning to trust it. That evening, X-299 and Vertel sent their findings to the Meraxian High Command. Their report included a phrase that would be studied for years to come. Humans have not abandoned mathematical precision in combat. They have transcended it. They use chaos as a scalpel, wielding unpredictability with surgical precision. Most remarkably, they have found ways to mathematically model factors we believed were beyond mathematical description: intuition, psychology, and the element of surprise. In his quarters, Carter reviewed the day's exercises. He knew the aliens were still struggling to understand how humans could deliberately introduce chaos into their combat mathematics and yet maintain control. But that was the beauty of the human approach. Control wasn't about maintaining perfect order. It was about riding the wave of chaos and directing it where you wanted it to go. Tomorrow they would show the aliens more, but Carter wondered if they would ever truly understand. After all, it had taken humanity itself a long time to learn that sometimes the best way to win wasn't to be better at following the rules. It was to change the rules themselves. Dr. Mary Thompson stood before the largest gathering of alien mathematicians ever assembled. The Galactic Council's main chamber was filled with beings from 30 different species, all waiting to understand how humans had changed the rules of space combat mathematics. Today, I'm going to show you something that will challenge everything you believe about combat calculations, she said, activating the holographic display. Above her, numbers and equations floated in the air, but they weren't like anything the aliens had seen before. High Chancellor Zira leaned forward on her floating platform, all 7 eyes focused on the display. These equations appear incomplete, she said. They are, Mary replied with a smile, because they include something your mathematics never considered: human intuition. Captain Richard Baker stood at the back of the chamber, watching the aliens' reactions. As a veteran space warfare instructor, he had seen that same look of confusion on many faces, even human ones, when they first learned about the new approach to combat math. Let me demonstrate, Mary continued. She pulled up a battle simulation. This is a standard space battle scenario. Watch what happens when we apply traditional mathematical solutions. The simulation showed 2 fleets meeting in space. The defending fleet used perfect mathematical formations and responses. The attacking fleet broke through in less than 5 minutes. Now, Mary said, watch what happens when we apply human intuitive mathematics. The simulation reset. This time, the defending fleet's movements seemed to make no sense. Ships went the wrong way. Formations had gaps, and energy readings fluctuated wildly. But somehow, these apparent mistakes worked together. The attacking fleet couldn't break through. This is impossible, one alien mathematician called out. The defending fleet's actions defy all mathematical logic. Dr. William Hayes, the human-alien relations specialist, stepped forward. That's because you're looking for pure mathematical logic. What you're seeing is human intuition translated into mathematical form. Mary nodded and zoomed in on one section of her equations. We discovered that human instincts could be mapped mathematically if we stopped trying to make them perfect. Instead of fighting against human nature, we found ways to calculate with it. The chamber erupted in discussion as aliens debated among themselves. High Chancellor Zira raised a hand for silence. Explain how you calculate something as abstract as intuition, she requested. Mary changed the display. We start with standard combat mathematics, vectors, energy distributions, shield harmonics. But then we add what we call human factors. Experience, gut feeling, the ability to spot patterns, even emotional responses. Captain Baker stepped forward. "I can show you how this works in practice," he offered. He pulled up the record of a recent battle he'd fought. "Watch my ship here. By pure mathematics, I should have turned left to maintain formation, but something felt wrong about that choice." The recording showed his ship turning right instead. Seconds later, an enemy ambush was revealed, exactly where he would have been if he'd followed mathematical logic. "How did you know?" asked an alien observer. "I didn't know," Baker replied. "Not in a mathematical sense. But after 20 years of space combat, I've developed instincts." Dr. Thompson and her team found ways to turn those instincts into mathematical principles. Mary brought up a new set of equations. "We created a mathematical framework that allows for human intuition. Instead of trying to calculate exact positions and responses, we calculate ranges of probability influenced by experience and instinct." She highlighted one section of the equations. "This part here. It's a mathematical representation of human pattern recognition. It's not perfect, but that's exactly why it works. It allows for the kind of creative thinking that pure mathematics can't predict." Dr. Hayes stepped in to explain further. "Think of it like this. Traditional space combat math is like trying to predict where a fish will swim by calculating water currents. Human intuitive math is like learning to think like the fish." The aliens watched as Mary showed more examples. Battles where human ships made seemingly illogical choices that led to victory. Training exercises where rookie pilots learned to trust their instincts while understanding the math behind them. "But how do you teach this?" High Chancellor Zera asked. "How do you train pilots to use mathematics that include intuition?" Captain Baker answered that one. "We start with the basics, traditional space combat mathematics. But then we teach them when to trust their gut, when to break from pure mathematical logic, and most importantly, why those breaks from logic can work." Mary pulled up a training simulation she used with new pilots. "Watch this exercise," she said. "The pilot has to navigate through an asteroid field. Traditional mathematics plots the safest course, but it's predictable. Our approach teaches pilots to use math to support their instincts, not replace them." The simulation showed a ship weaving through asteroids in a way that looked random but somehow felt right. The path wasn't mathematically perfect, but it was surprisingly effective. "The real breakthrough," Mary explained, "was realizing that we didn't need to choose between math and intuition. We found a way to use both together. The math helps guide the intuition, and the intuition helps show where the math needs to be flexible." As the presentation continued, the alien mathematicians began to understand. They saw how human combat mathematics wasn't flawed or primitive. It was evolved. It had grown to include factors they had never thought could be calculated. Later that evening, High Chancellor Zera called a special session of the Galactic Council. The decision was unanimous. Human combat mathematics would be studied and incorporated into their own training programs. In her quarters that night, Mary reviewed the day's events. She looked at the equations that had taken her team years to develop, the mathematical framework that finally bridged the gap between pure calculation and human instinct. "They're starting to understand," Dr. Hayes said, joining her. "Though I think it will take time for them to fully accept that sometimes the best mathematics isn't about finding the perfect answer." Mary nodded. "It's about finding the human answer," she said. "And sometimes that's better than perfect." Captain Baker, looking out at the stars from the station's observation deck, smiled as he watched alien ships practicing some of the new maneuvers. They were still too rigid, too focused on getting it mathematically right. But they were learning. They were learning that in the vast darkness of space, the best calculations weren't always the ones that looked good on paper. Sometimes, they were the ones that just felt right, backed by mathematics that weren't afraid to embrace the beautiful imperfection of human intuition. The TSS Valiant hung in space like a silver arrow, its hull gleaming under the light of distant stars. Captain Diana Scott stood on her bridge, watching as the Galactic Council's test fleet took formation around her ship. Today was the day they would prove that human combat mathematics worked in real situations, not just in theory. "All stations report ready," Lieutenant Paul Martinez said from his navigation console. His fingers moved steadily over the controls, preparing for the demonstration. Grand Strategist Eknar's voice came through the comm system. "Captain Scott, are you prepared to begin the joint exercise?" "Ready when you are," Diana replied calmly. She knew what was coming. The aliens would try to prove that their traditional mathematics could counter human tactics, now that they understood them better. Dr. Catherine Brown sat at her station, monitoring the combat analysis systems. She had helped design this demonstration to show exactly why human methods worked so well. "Beginning Standard Combat Scenario 1, Eknar announced. 5 alien ships moved into a perfect attack formation, their positions mathematically precise. Diana smiled. "Show them what we can do, Lieutenant Martinez." Pattern Sierra 3. The Valiant suddenly spun on its axis, burning its engines in what looked like the wrong direction. The alien ship's computers tried to predict where the human vessel would be, but they couldn't make sense of its movement. "Interesting choice." Eknar's voice held a note of confusion. "You're burning fuel needlessly." "Am I?" Diana asked. The Valiant's strange movement had forced 3 of the alien ships to adjust their formation. Instead of their perfect pentagon, they now had to spread out to maintain targeting solutions. Dr. Brown spoke up, explaining for the observers. "Watch how our wasteful maneuver has actually split their formation. We're not trying to be efficient, we're trying to make them inefficient." The alien ships attempted to correct their positions, using perfect mathematical calculations to close the gaps in their formation. But that's exactly what Diana had expected them to do. "Now, Lieutenant," she ordered. The Valiant surged forward, straight through a gap that had appeared for just 2 seconds. In a real battle, they would have scored direct hits on 2 of the alien ships before they could react. "Impossible," one of the alien commanders protested. "Our formation was mathematically sound." "Your formation was predictable," Diana corrected kindly. "You responded exactly as your combat mathematics said you should, and that's what we counted on." Grand Strategist Eknar called for a pause in the exercise. "Explain your reasoning, Captain Scott." Diana nodded to Dr. Brown, who pulled up a tactical display. "We knew you would try to maintain optimal firing positions based on standard combat mathematics. So we created a situation where following those mathematics would actually work against you." Lieutenant Martinez added, "It's like a game of chess where we make moves that look wrong to force our opponent into moves that are technically right but strategically weak." The exercise continued. Each time the alien ships tried to use their perfect formations and mathematically precise maneuvers, the Valiant found ways to turn that precision into a disadvantage. "Watch this next demonstration carefully," Diana announced. "We're going to show you why trying to be perfect in combat can be dangerous." The Valiant began what looked like a standard attack run. The alien ships moved to counter it, their computers calculating the optimal defensive positions. But at the last second, the human ship did something that made no mathematical sense. It cut its engines completely. "They're dead in space," an alien observer exclaimed. "Their momentum will carry them right past the optimal firing position." But that was exactly what Diana wanted. As the alien ships adjusted to target the expected optimal position, the Valiant used its maneuvering thrusters in short, seemingly random bursts. Each burst looked inefficient and wasteful, but together they created a pattern of movement that the alien targeting computers couldn't predict. "This is what we call controlled chaos," Dr. Brown explained to the observers. "Every random thrust is actually carefully calculated to create confusion in enemy targeting systems." The alien ship's weapons fired, but their shots went wide. They had aimed where their mathematics said the Valiant should be, not where it actually was. But this defies logical combat principles, Eknar protested. Your ship is using more energy and taking longer to achieve its objectives. Diana smiled. Our objective isn't to be efficient. It's to stay alive and complete our mission. Sometimes the longest way around is actually the safest path forward. As the exercise continued, the aliens began to see the pattern behind what looked like chaos. The Valiant never did anything truly random. Every move was calculated, but calculated differently than traditional combat mathematics would suggest. It's like watching a dancer, one alien observer noted. The movements flow together in ways that don't make mathematical sense, but are obviously effective. Lieutenant Martinez grinned at the comparison. That's not far off. We train to make our ships move in ways that feel natural to humans, but look chaotic to targeting computers. After several hours of demonstrations, even Grand Strategist Eknar had to admit that the human approach had merit. Your methods are unorthodox, he said, but I cannot argue with their effectiveness. Dr. Brown spent the rest of the day explaining to curious alien observers how they trained human crews to use these tactics. We start with basic combat mathematics, she said, but then we teach them to trust their instincts about when to break from standard patterns. In her quarters that evening, Diana reviewed the exercise recordings. The alien ships had performed exactly as their combat mathematics dictated, and that had been their weakness. Their perfect precision had made them perfectly predictable. It's ironic, she said to Martinez as they discussed the day's events. They thought we were being inefficient and chaotic, but every move we made was planned to take advantage of their mathematical perfection. That's the beauty of human combat mathematics, Martinez replied. We don't try to be perfect. We just try to be better than the enemy expects us to be. As the Valiant prepared for the next day's exercises, Diana knew they had shown the aliens something important. Perfect mathematics might work in theory, but space combat wasn't theoretical. It was real, messy, and unpredictable, just like humans themselves. And sometimes, being unpredictable was the best strategy of all. The new human Galactic Mathematics Institute stood proudly on Earth's moon, its crystal domes reflecting both Earthlight and starlight. Dr. Stephen Morris walked through its main hall, looking at the mixed groups of humans and aliens studying together at various workstations. Just 6 months ago, this would have seemed impossible. Quite a change from when they thought we were doing everything wrong, Admiral Linda Parker said, joining him on his morning walk. The Admiral had been key in convincing the Galactic Council to establish this joint learning center. They're still struggling with some concepts, Stephen replied, watching an alien instructor try to explain human intuitive mathematics to his students, but they're learning. In one of the training rooms, Professor Elizabeth Cole was teaching a mixed class of human and alien students. On the large screen behind her, combat simulations played out showing both traditional and human-style tactics. The key isn't choosing between pure mathematics and human intuition, she explained to her class. It's learning when to use each one and how to combine them. Supreme Calculator VIX 871, once one of the strongest critics of human mathematics, now stood at the back of Elizabeth's classroom. The alien's color shifted to show interest as the professor demonstrated a new concept. Watch what happens when we apply traditional mathematical principles to this scenario, Elizabeth said, starting a simulation. The ships moved in perfect patterns, their formations flawless. Then she changed the parameters. Now let's add human intuitive factors. The same ships began moving differently, their patterns less perfect but somehow more alive. But how do we know which approach to use? Asked a young alien student, their learning crystals glowing with confusion. That's exactly the right question, Elizabeth smiled. And that's what we're here to learn together. In another part of the Institute, Admiral Parker met with the Galactic Council's Education Committee. The large chamber was filled with representatives from 20 different species, all eager to discuss the progress of the joint training program. The results have exceeded our expectations, Parker reported, showing the latest training statistics. Mixed crews using both mathematical approaches are outperforming crews using either method alone. Supreme Calculator VIX 871 joined the discussion. We have discovered that human inefficiency often creates advantages we had never considered. Their willingness to sacrifice mathematical perfection for tactical advantages, fascinating. It's not really about being inefficient, Dr. Morris explained. It's about understanding that the shortest path isn't always the best path. Sometimes you need to take the unexpected route to achieve your goal. In the Institute's combat simulator, a mixed crew of humans and aliens was running through a complex battle scenario. The human pilot made a decision that seemed to go against mathematical logic, but the alien weapons officer immediately understood the strategy and adjusted their targeting to take advantage of it. They're learning to work together, Elizabeth observed, watching the exercise. The aliens are becoming more flexible in their thinking, and our people are learning to better understand the mathematical principles behind their instincts. Admiral Parker smiled as she watched the simulation. That's exactly what we hoped would happen. We're not just teaching each other new ways to fight. We're learning new ways to think. In his office, Dr. Morris reviewed the latest research papers from the Institute's students. One alien mathematician had written a fascinating analysis of how human intuition could be mapped mathematically without losing its unpredictable nature. A human student had discovered ways to make traditional alien combat formations more adaptable by introducing controlled variables. We're creating something entirely new, he told Parker when she joined him. Not just human mathematics or alien mathematics, but a combination that's better than either one alone. The Admiral picked up one of the papers. Look at this, she said, showing him a diagram. They're already developing new combat maneuvers that would have been impossible under either system alone. The aliens provide the mathematical precision, and our people add the creative elements that make it unpredictable. In the main simulation chamber, Elizabeth was overseeing a major test of these new combined tactics. A fleet using the hybrid approach faced off against fleets using either pure mathematical or pure human methods. The results were striking. The hybrid fleet is consistently outperforming both traditional approaches, she reported to the gathered observers. They have the precision to execute complex maneuvers, but the flexibility to change plans when necessary. VIX 871's crystals pulsed with excitement as they analyzed the data. We are seeing a 23% improvement in combat effectiveness. The combination of approaches creates possibilities we never imagined. Later that day, in the Institute's central gathering area, humans and aliens mingled freely, discussing new ideas and sharing insights. Young alien students practiced making intuitive decisions, while human cadets learned to better understand the mathematical principles behind their instincts. Look there, Dr. Morris said to Parker, pointing to a group where an alien mathematician was excitedly explaining a concept to a human pilot, using both equations and hand gestures to get their point across. That's the real victory, Parker replied. Not just teaching each other our methods, but learning to see things from each other's perspective. Elizabeth joined them, carrying new simulation results. The latest tests are even better than we hoped. The new hybrid combat mathematics is proving more effective than anyone predicted, because it takes the best of both approaches, Morris nodded. The aliens' mathematical precision gives structure to human intuition, while human creativity helps break free from the limitations of pure mathematics. As the day drew to a close, the Institute's domes lit up under the Earthlight. Inside, the work continued as humans and aliens together wrote the next chapter in the story of space combat mathematics. You know what the best part is? Parker said to Morris as they watched the activity. We're not just learning better ways to fight. We're learning better ways to understand each other. Morris smiled, watching an alien student successfully complete their first intuitive combat maneuver, while their human classmates cheered them on. That's the real breakthrough, he agreed. We've proven that different ways of thinking aren't obstacles to overcome. They're advantages to be combined. In the end, what had started as a puzzling discovery about human combat mathematics had led to something much more important. A new understanding that the best solutions often came not from choosing between two different approaches, but from finding ways to use them together. As night fell on the lunar surface, the Institute continued its work, its lights shining like a beacon of cooperation and progress. Inside its walls, humans and aliens worked together to create something new, a future where the precision of pure mathematics and the unpredictability of human intuition combined to create something greater than either could achieve alone.